Hello friend, welcome to online lecture series. Today we will just continue with reduction formulae. So let's start the today's topic, that is standard conversion of the reduction formulae. Yesterday's lecture we already saw the reduction formulae of your cos and sine, where the limit of your integration goes from 0 to pi by 2. There are two formulas of your sine and cosine. It depends on n. If n is even, then what is the reduction formula for your sine and cosine, whose index is n, which is greater than 2. Similarly, reduction formula for sine and cosine for n is odd. The first, we will see the standard conversion of this reduction formulae when the limit get changed is from 0 to pi. So first we just see the previous, how the reduction formula is found by simplification of the integration. So here for n is even, then the reduction formula for your either cos or sine, whose index is n, is the ratio of the real numbers up to 1 upon 2 is multiplied by pi by 2. The formula is n minus 1 upon n minus 3 upon 2, n minus 5 upon n minus 4, n minus 7 upon n minus 6. We have to just subtract the real number starting from 1 up to subtraction is 1. So we continued, we get 3 upon 4, 1 upon 2. If my n is even, this ratio multiplication is get multiplied by pi by 2. In similar manner, we already find the reduction formula for cos and sine if your n is odd. The reduction formula for your sine and cosine is again n minus 1 upon n minus 3 upon n minus 2, n minus 5 upon n minus 4, n minus 7 upon n minus 6, up to 4 upon 5 is multiplied by 2 upon 3, and lastly is multiplied by. These are the two standard reduction formula defined for sine and cosine, whose index is n. It depends on even and odd. If the limit of your integration is changes from 0 to pi, so we already defined two reduction formula of cosine and sine if n is my even or odd for the limit 0 to pi by 2. What happens when the limit of the integration is 0 to pi? Then we have to reduce this particular integration in the standard form, and that first form is, if my n is even, then reduction formula is 2 times integration goes from 0 to pi by 2 cos raised to n of x dx. Means it totally depends on your value of your n. If n is my even, we have to just get 2 times. If n is my odd, we get directly answer equal to 0. Means when we just find the integration of your this 0 to pi cos of raised to n of x dx, the answer is 0. In the similar manner, we just define the standard conversion formula for your sine, whose index is n and limit runs from 0 to pi. There is no any restriction on your n. Means for any n, we can write this particular integration 2 times 0 to pi by 2 sine raised to n x dx. In cos, we have to identify whether my n is even or odd. If n is even, 2 times. If n is odd, directly its value is 0. For sine, always we have to reduce the formula in 2 times integration 0 to pi by 2 sine raised to n x dx. Again, we change the limit from 0 to 2 pi. At that time, what is my reduction formula for your cos and sine? For the cos and sine, the reduction formulas both are equivalent, both are same. So, if the integration runs from 0 to pi by 2, 0 to 2 pi, cos index is n, x dx is 4 times integration 0 to pi by 2 cos raised to n x dx. It is possible if n is even. In a similar way, if the index of your sine is n and limit goes from 0 to 2 pi, again if n is my even, then it is 4 times the integration 0 to pi by 2 sine raised to n x dx. And if n is odd, in both the formulae, the integration of your cosine or sine are defined in the interval 0 to 2 pi. The value of that integration is directly 0. So these are the 4 different standard conversions of the reduction formulae. It depends on the limit of your integration. The most important note is that the argument, or we say that the theta or the value which is present inside your sine or cosine, the observation is here, the coefficient of your this x is always 1. Means here there is no any constant is multiplied to your x. Means the x is whose coefficient is 1. If the coefficient of your x is other than 1, so we have to convert that particular terms in single variable whose coefficient is always 1. Then and then this all the formulas are applicable to find the value of such a integration. If the coefficient of your x is not 1, then we cannot use this reduction formula directly. Also, we will see the examples based on this. The example number first is we have to find the integration's value. In that integration, whose limit is goes from 0 to pi, sine function's index is 8, and we have to find its solution. First, we have to this. If the integration sine raised to n is 2 times integration 0 to n, yes, and this is for any of your n is given, so we have to find. Again, in addition formula for your sine, whose index is n, limit from 0 to pi by 2 is n minus 1 divided by n, n minus 3 upon n minus 2 up to 1 by 2 into pi by 2. So we have to replace the value of your n is equal to 8 in this formula, and this answer is get multiplied by 2. We get a solution for the integration who runs from 0 to pi sine raised to nx dx. So So here I8 equal to integration 0 to pi sine functions index is 8. It means my x variable in that the value for n is my 8. So 2 times integration 0 to pi by 2 sine raised to 8 x dx, it becomes 2, 7 by 8, 5 by 6, 3 by 2, 1 by 2, and lastly 5 by 2. Means replacing the value here and we got these multiple ratios, and multiplying we get a final solution. So this 2 and this 1 by 2 get cancelled, and remaining particular terms multiplication 7 into 5 into 3 becomes 105. Pi remains as it is. 8, 6, 4, 2. Its multiplication is 380. In this way, we can find the solution for such a integration. We will move for the second one. Here, again, the index of your sign is 9. It means it is a odd. And we know that if sign function is odd, even the number we have to just that particular reduction two times. And again, we know that standard formula of sign, example number second also. Here n is equal to 9. So replacing the value of your n is equal to 9 in this, we get the final solution, that is a 3 from your pi, that is a 786 upon 945 is my solution. In a similar way, we can find the value of your integration whose limit from 0 to pi. In that, functions are functions, and that containing for your cos whose index is n, it's 6, and that is even. So we know that if n is my even, the formula is reduced to 2 times the standard reduction formula of your cosine. So we have to replace the value for n is equal to 6. It's our standard 2 into 5 upon 6, 3 upon 4, 1 upon 2, and pi by 2. Again, the 2 to get cancelled, and in terms 5 upon 6, 3 upon 4, and pi upon 2. The final solution is 15 pi upon 48. So, in a similar way, if we take the index of your cosine is suppose odd, then what happens? We know that if my n is odd in my cosine function, then the value of such integration is directly 0, because it is a no any standard reduction. It's 2 times some integration or what, that is not possible here. So here n is odd, directly answer of such integration is 0. In this way, we can find the value of your all the integration whose limit ranges from 0 to pi. So in the next lecture, we will see the next reduction formulae of